Hi everyone, this is Akshaya. I'm from IIT Madras and I'm from electrical branch. So today we are going to learn about the rectangular Cartesian coordinate system. And so how do we start? We'll start it from the why do we use this Cartesian coordinate system? Usually when we want to locate a point in a space, we usually use this coordination system. So if you want to locate a point in a space which is particularly two-dimensional plane, you can use this coordination system. So here you have to know some points like x4, x dash and y0, y dash in the screen that you can see. Those two are the lines of the plane which are called as x-axis and y-axis. So these two lines divide the space into four parts which are known as quadrants. Quadrant 1, quadrant 2, quadrant 3 and quadrant 4. So yeah, so these four quadrants have different properties. Like if you have a point located in the quadrant 1, you can say that the point has two positive x coordinate and y coordinates. And if you see that the point is in the quadrant 2, the x coordinate is negative and the y coordinate is positive. So yeah, in that way you can write for the quadrant 3 and the quadrant 4 also. So as I said, x4, x dash and y0, y dash are the two perpendicular lines which divide the space into four parts. So OX part is considered as positive and OX dash is considered as a negative thing. And OY is the positive y-axis and OY dash is the negative y-axis. And combinedly, these two lines are called as coordinate axis. And the point which is the intersection point of these two lines is called as origin. The coordinates of those two of the origin is called as origin of the coordinates. And if the lines doesn't make 90 degrees and if they are not perpendicular, if they have an angle, then this is called oblique axis. And as if you can see, if you want to know the x coordinates and y coordinates of a point with respect to these two lines, then you can draw a rectangle, which is nothing but a projection from P to the line OX in a perpendicular manner, and as well as in the OY, which is M. And those two PM and OL are same, which is nothing but x coordinate, which is also called as abscissa. And the OM line and PL line are the y coordinates, and it is also known as ordinate. So we usually denote it by x comma y, and this is called as the Cartesian coordinates of one. We can also represent this point, location of the point, by using another coordinates also, which is polar coordinates. So going from this, we'll just note 2 points that if a point is lying on the x-axis, then the y-coordinate of the point is 0. As you can see, if there is any point lying on the axis x or x, then the point has y-coordinate as 0 because the PL length would be 0. And similarly, if there is any point which is lying on y o y dash, then the point has x-coordinate as 0 as OL length would be 0. So, and also the coordinates of the origin, which is nothing but the reference for all our locations, is 0, comma 0. So, polar coordinates. We'll move on to the polar coordinates. So, polar coordinates, as in the previous case, we have measured the distances between the origin and that point with respect to the x-axis and y-axis. But now we'll just see the distance directly from the point to the O and the angle made by the point OP, by the line OP with the x-axis, which is nothing but theta. As you can see in that picture, the point is denoted by r comma theta, and the angle made by that point, I mean the line OP, is theta with the x dash OX, and the distance between OP is r. So we usually, if we have some circles out of questions, we can use this polar coordinates, which makes us do the simplification easy. So as if you want to convert the coordinate system, polar coordinates to the Cartesian coordinates, then you can use this formulas. As you can see, the r cos theta would be the x value and r sin theta would be the y value. As you can see from the diagram itself. And the r value would be the root over x square plus y square. As you can see, r square cos square theta plus r square sin square theta, which is r. Um, so, and the angle is x by y or tan inverse of y by x. And if you want to find distance between 2 points, if you want to find distance between P and Q, as you can see in that picture, which has coordinates x1, y1 and x2, y2, and the distance is root over PR square plus QR square. So PR square, as if you can see, there is a right angle triangle there with respect to R. So PQ is the hypotenuse, and then you can find the hypotenuse measurement by PR square plus QR square, square root of, and that you can get it as root over x2 minus x1 whole square plus y2 minus y1 whole square. And if you want distance from origin, which is the reference point, that is root over x naught square plus y naught square, because here x1 and y1 are 0, comma 0. So if the distance between 2 points is given, then you will have to use plus or minus symbol. As if you can see that if there is a point in the third quadrant here in the first diagram, then the distance OP, if it is positive, then the distance OP dash would be negative, as it is in the opposite direction and with the same distance. So we have to use plus or minus symbol there. And when the line PQ is parallel to the y-axis, then the axis of point P and Q will be equal, as uh, it is parallel to the y-axis. So the x coordinate would be same. So the distance between those two would be y2 minus y1 mod. As we are measuring the distance, it should be always positive. So we use mod symbol there. And when the segment is parallel to the x-axis, and the vice versa, we'll take mod x2 minus y1, x1 as y1 equal to y2. And if you have 2 points represented in the polar coordinates, and if you want to measure the distance between those two coordinates, then we have a formula here, root over r1 square plus r2 square minus 2r1 r2 cos theta, 1 minus theta. And this formula has a proof, as if you can see in the picture, P comma Q are those 2 points which we wanted to measure the distance between. And theta 1 and the theta 2 the angles. As you can see, you can form a triangle between those 2 points by using the triangle law. We have that cosine law also. POQ, the distance between those two, PQ would be angle. If you know the angle between the POQ and the distances between OP and OQ, then you can find the PQ by the cosine law, which is nothing but root over PO square plus OQ square minus 2 into PQ cos theta, where theta is the angle between those two. And we have to ensure that theta 1 and theta 2 are in the radians. Most probably the questions will be in the degrees, so we have to convert it to the radians, and then we have to find the distance. And then we'll see some problems so that you will get the clarity. Uh, so here we have a point x comma y, which is equidistant from the points a plus b comma b minus a and a minus b comma a plus b. So we have to find the equation of the x comma y. We have to somewhat find the locus of the point x comma y. So as as they said, the distance between those 2 points are same. So we'll write that point as P, and PA is equal to PD. So what do we do? We'll just square both sides, and then PA we know that root over a plus b minus x whole square plus b minus a minus y whole square. So by squaring it, both sides will get this equation, and if you solve this equation, you will get an equation which is nothing but bx minus ay equal to 0. So by that we can say the fourth option is the correct one. And so here what we did is we just took the distance formula, we used distance formula, and then we solved for the equation. That's it. So we'll go for the next question. Here they gave the coordinates of a point 2, 3, 1, and we have to convert it into the polar coordinates. As we can see here in this page itself, we know how to convert the point if there is a polar coordinate into normal coordinates. So we are doing it here vice versa. We can do it by same, but do it in the reverse process. So here we know that x equal to r cos theta and y equal to r sin theta. As we know that x equal to root 3 and y equal to 1, root 3 equal to r cos theta and 1 equal to r sin theta. So by squaring on both sides, we will get the r value. So r equal to 2 and theta equal to tan inverse of x by y. So by that we can get the polar coordinates. And we are going for, will generally get the questions in this form. or else we'll get questions on the polygons or some sort of coordinates questions on that. So we'll just revise the properties of triangles and quadrilaterals, as it will be useful for us when we do some questions in the next pages. And so when we come to the properties of triangle, we all know that in a triangle ABC, the sum of any two sides would be greater than the third side, and the difference between distances between any two vertices of two sides would be less than the third side. So, and if you have an equilateral triangle, all sides should be same. And if you have a right angle triangle, the hypotenuse is nothing but the biggest side in the right angle triangle would have value of root over the other squares of sum of the squares of the other two sides, which is nothing but AB equal to root over AC square plus BC square, or any other side can be written in that way according to it. And also in a isosceles triangle, any two sides should have same length. So, and we'll go further for the quadrilateral. If any quadrilateral is known as a parallelogram, it should satisfy these two conditions, that AB is equal to DC and AD equal to BC, which is nothing but the opposite sides should have the same length, and the middle points of the diagonals should be intersecting at the same point. At that point, it should be the middle point of those two diagonals. So we can frame it in this way also. The intersection point of those two diagonals would be the midpoint of those two diagonals. And the diagonal shouldn't make angle of pi by 2, as it is clearly mentioned as a parallelogram. So, and if we have a quadrilateral which is known as rectangle, then it should satisfy these conditions, that the opposite sides should be equal and the diagonal length should be a square root of AB square plus BC square. And if you see for AC, the diagonal length should be square root of AB square plus BC square. If you see for the BD, it should be square root of AD square plus AB square. And also, the diagonal length should be same. And you can easily understand why the diagonal length should be same. And also, the middle point of the diagonal should be the same. And the angle between the diagonals shouldn't be pi by 2. And if any quadrilateral is known as rhombus, which is not mentioned as a square, then the all sides should be same and the diagonal length should not be the same. And the middle point of AC and the BD, which is nothing but the diagonal, should be the same. And AB should be equal to AD, which is nothing but the sides should be equal, but the diagonal shouldn't be equal. And the angle made by the diagonal should be 90 degrees. And if it is square, it should be 90 degrees and the diagonal length should be same. So by this, we'll close the properties. And we also need to note that the diagonals of all these quadrilaterals, which I mentioned before, should have a same middle point, which is nothing but the intersection point of the diagonals should be the middle point of those. And diagonals of a rhombus and a square should be at 90 degrees. And if you have any 4 points, which is called collinear, which is nothing but lying on the same line, then the area formed by those 4 points should be 0, as there won't be any quadrilateral forming there. So the enclosed area would be 0. So we'll see some examples as we know these properties. So here we have an example. Here the question says that ABC is an isosceles triangle, and if the coordinates of the base are B and C, 1, 3 and minus 2, 7, the coordinate of vertex A can be. So here we have 2 points and we need to find the third point. So in an isosceles triangle, we know that the any two sides should have same length. So here we can assume AB and AC can be same. So we have to solve it. As we know the distance formula, AB distance would be x minus 1 whole square plus y minus 3 whole square, and AC distance would be x plus 2 whole square plus y minus 7 whole square, square root of. And if you're squaring on both sides, then you'll get this equation. And from the options, you can see that which are the points which are lying on that line, which are satisfying the equation. But you shouldn't consider the point minus half comma 5 because it is in the midpoint of the BNC line, which is not which doesn't form a triangle if the point other vertex will be lying on the same line. So you shouldn't take that point, and you have to take the point which is lying, which is nothing but 5 by 6, comma 6 in the option. So we'll go for the next example. Extremities of a diagonal of a parallelogram are the points 3, comma minus 4 and minus 6, comma 5. And if the third vertex is minus 2, comma 1. As I said previously, the diagonal should have the same midpoint. So here we have two diagonal vertices and the third diagonal vertex. The fourth vertex we need to know. So we can use that property and we can solve the equation to get the x comma y value here. So that's what we did here. And when we solve it, we'll get the x comma y values as minus 1, comma 0. And if you see the next question, here we know that A, B, C, D are the square vertices and we have the C vertex 12, comma 17. We need to know the vertex of B. So here what you will do is, here we'll assume the angle made by the AB line with the x-axis as theta. And if you take it as a theta, as you can see the angle BAD is 90 degrees and OX is a straight line. So the angle BAO would be the 90 minus theta, as the sum of these angles on OX would be 180 degrees. So as it is 90 minus theta, the angle made by ODA would be theta, as it is forming a right angle triangle. And in the similar way, if you see for the upper one, which is a right angle triangle, you can find that angle MCD would be theta. So here we know that here if you can see the diagram, you can understand it clearly. And here we know that vertex C is 12, comma 17. So CM would be 12. And we know that if we assume the side length as A, then CD would be 5 because A cos theta is 12. So A in the similar way, A cos theta, where AD is A, and OD would be A cos theta, which is nothing but 12 again. And here similarly, AI would be 12 as A cos theta. The length is A cos theta. So it is 12 and 12. This is 12. As you can see, the point made by the y coordinate of the C is 70. In the similar way, you can say that the A sin theta would be 17 minus 12, which is nothing but 5. So from that, you can say the BL is 5. And in that way, A sin theta is 5. So the B vertex would be 5 and 5 plus 12, which is nothing but 17. So the coordinates of B is 17, comma 5. From here, you can solve it. And for the next example, you have triangle with vertices 4, comma 0, minus 1, comma minus 1, and 3, comma 5. So whenever you are given to three vertices, and if they ask how to, and then if they wanted to know what type of triangle it is, then you have to find the distances first. So as you can see, the distances between all those three vertices or the sides would be root 26, and root 52, which makes us a right angle triangle at the angle A, which is opposite to the side BC. So here we can say that it is a right angle isosceles triangle. And we'll go to the next section, which is section formulae. So what is a section formulae and what do we get from that? So here if we have a 2 points in the space, A comma B with the coordinates x1, comma y1 and x2, comma y2. And if you have a point x, comma y which divide the line segment formed by these 2 points in the ratio m1 is to m2 and clearly mention that m1, comma m2 is greater than 0, then there are two types of division. If the point lying on the line segment internally divides it, then the formula would be x equal to m1x plus m2 x1 by m1 plus m2 and y coordinate would be in the similar way. But if you have that point dividing the line segment in the external way, like the outside of the line segment, but extension of the line segment, then the formula would be m1 x2 minus m2 x1 by m1 minus m2 and m1 y2 minus m2 y1 by m1 minus m2. So in this way, you can say the point value. As you can see in the picture, the point is outside the line segment, but the extension of the line segment. So here we have to note some points which makes us solve the equations easily. So one note is if the point is dividing the line segment A and B in the ratio lambda is to 1, you most probably would say lambda is to 1 because m1 by m2 we can make m1 by m2 is to 1. So we mostly say lambda is to 1. So you can easily decrease the writing thing as m1 is to m2 as lambda is to 1. So in that way, you can just find the x comma y coordinates there. Or if you want the ratio, you can just find the lambda there. And if you have a if you want to find the midpoint, so which is nothing but x1 plus x2 by 2 and y1 plus y2 by 2. Here m1 is to m2 is 1 is to 1. And the lambda is negative. Then if the question mentions that it is dividing internally, if they want the ratio, which is the point making it internally division, but when you solve the question, if you get the lambda as negative, that means that the point is externally dividing it. So in that way, you can just ensure what's the thing happening there. And if you have a straight line, x plus by plus c equal to 0, dividing the join of the point a and b in the ratio minus x1 plus by1 plus c by minus ax2. Yeah, in that way. And so we'll solve the question. The coordinate of the points dividing internally the line segment joining the points. Here we have the A and B point at the ratio thing. I can find the point directly from the formula. And here we have a line which is dividing the line segment minus 1 comma 1, 5 comma 7. As we know the formula, we'll apply it. And here we will get the ratio as positive. So it is nothing but the internality. And if there is a line joining point, we'll go for the next question. The line joining points 2 comma minus 3 and minus 5 comma 6 is divided by the y-axis in the ratio. So here we don't have the coordinate directly. And here they mention that it is a y-axis coordinate. So whenever a point is lying on the y-axis, the x-coordinate should be 0. So whenever you take the x-coordinate as 0, you will find that if the ratio is k is to 1 or lambda is to 1, so the point would be k into minus 5 plus 1 into 2 by k plus 1. From there, you will find the k value. And we'll go for the next section, which is points of triangle. So we usually have some main points in the special points in the triangle. So we'll go it by one. And the first point is centroid. So centroid is nothing but the intersection of the points, sorry, intersection of the lines, uh, which are the medians, like intersection of all the medians of the triangle. So the centroid is the point, right? So it divides the median in the ratio 2:1. As if you can see in the diagram, AD, BE, and CF are the medians, and G is the centroid. And you can see that G is dividing the AD line segment in the ratio 2:1. So if you know the coordinates of A and D, you can find the G value. So here we know the D coordinates are midpoints of the B and C, and A you know, and from that you can find the G. So directly we'll write the formula here, which is G equal to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So we'll solve an example. So center of a triangle is given and two vertices are given. You have to find the third vertex. So for that, you know the formula. So by using that formula, you'll get the x comma y here. Here the vertex is 4 comma 7. And when we come to the next point, which is circumcenter. The circumcenter is the intersection point of the perpendicular bisectors. So what are the perpendicular bisectors here? And if you have a triangle like ABC, the BC line has a perpendicular bisector. Here D is the midpoint and a line drawn from it, a perpendicular line. So in the similar way, if you draw perpendicular bisectors for AB and AC, you'll get a OF and OE and OD, where O is the circumcenter. And the speciality of this triangle and the circumcenter point is if you draw a circle from O to the vertex, and if you continue the circle, then the circle passes through ABC, all the points of the triangle. And this is called a circumcircle. And so here we know that the OA and OB and OC should be same because it is a radius in the circle. So OA equal to OB equal to OC. And from that you can find the O. And usually we'll use a formula if we know the angles of the triangle. So which is x1 sine 2a plus x2 sine 2b plus x3 sine 2c by sine 2a plus sine 2b plus sine 2c, and similarly the y coordinates. And here ABC would be the angle. So we'll solve some questions. So here we know the coordinates 2 comma 1, 5 comma 2, 3 comma 4, and we need the circumcenter. So as I said, as a as the distance between O and A and OB, OC would be same. So we'll write the equations. We will write the first equation, OA square equal to OB square, and the second equation, OA square equal to OC square. And when we solve these two equations, we'll get the x comma y coordinates. And there is another point which is called in-center. So the in-center is the point of intersection of the internal bisectors of the angles of the triangle. So as you can see, the AD line, CF line, and BE line are the angular bisectors of the lines. I mean the angles formed by ABC, BCA, and CAB. So when these three lines are drawn, the lines intersect at a point called in-center, which is denoted by I. And here circumcenter is denoted by O or S. And so here in-center, the coordinates is given by the formula ax1 plus bx2 plus cx3 by a plus b plus c. And similarly the y coordinates. Here ABC is nothing but the side lengths of the triangle ABC. Here side length BC would be A, and similarly for the other two sides. And the next point is x circle or x center. So what is meant by x circle? So if you have a triangle ABC and when you extend the line AC, BC and AB, you'll get the extensions. And if you draw a circle which is touching BC and the extensions of AC and AB, then the circle is known as x circle with respect to A vertex or the BC line. So these are called, we'll get three X circles. So these three X circles have a center point, which are known as X centers. And here we can also state this X center point in other ways also. Like if you have the extensions in the similar way, like the same diagram, and if you have a external bisector, if you have AB external angle, then the bisector will pass through the bisectors of the angle CAB would be passing through the same point, and also the angle between uh, what do you say? The angle between BAC also passes through the same way. So in that way, we can say that X center is the point of the is the intersection point of the external bisectors and the other two internal bisectors. So in that way, you can state the x centers. And here also we have some formulas for the x centers, I1, I2, I3. And what you'll do is if you want x center with respect to side BC or A, you'll just reverse the sign of the A. And if you want for B, then you'll sign it B. Angle bisector divides sides in the ratio C is to B. So if you can see here, if you want to know the angular bisector division the ratio, it would be the other two sides ratio. So, and see, as you can see here, as I said, center would be the intersection points of one internal angular bisector, and the other two external angular bisectors. And this is also called as this is called as center. So we'll solve the questions. So the incenter of the triangle with vertices. So here they gave the vertices of the triangle, and we need to find the incenter of the triangle. As you can see that those three vertices form an equilateral triangle. So we will get to know that the all points in an equilateral triangle coincide. So the incenter and centroid, circumcenter, everything would be the same thing. So here we'll just find the centroid here, and as it is same as in center, we'll just write it as, we'll just use that formula. So here the formula for the centroid would be x1 plus x2 plus x3 by 3. So here we'll just use it. And orthocenter, the next point, which is the intersection point of the perpendiculars drawn from the vertices, which is nothing but altitudes. So here you can see the A, B, F, and CD are the altitudes which are dropped from the ABC vertices, and they have a intersection point called as orthocenter. And here the orthocenter, we can find the orthocenter by knowing these two properties, that A is perpendicular to BC and OE is also perpendicular to BC. So in that way, you can just write some equations to solve, and you will get the O. And if you have a triangle which is right angle, then the orthocenter would be the middle point of the hypotenuse. So if you have a right angle triangle vertices, then you can just find the middle point of the hypotenuse vertices, and then there you go, you'll get the orthocenter. And if the triangle is equilateral, as I said, all those 3 points would be coinciding. So the incenter, orthocenter, and the circumcenter would be the same. So if you want to find the orthocenter, you can just find the third tribe, and it would be the same thing. And if you know the orthocenter and centroid, you can just find the circumcenter, or if you know any two of them, you can find the other coordinates by knowing the fact that these three are on the same line, and the centroid divides the line joining the orthocenter and circumcenter in the ratio 2:1. So in an isosceles triangle, centroid, orthocenter, and incenter, circumcenter, they are on the same line. So here we also include the incenter too, as it is an isosceles triangle. So for the 13th question, we'll see what is the question asking for. And here we know the vertices of the triangle. We need to find the orthocenter. As you can see, it is a right angle triangle. So the right angle triangle orthocenter would be the middle point of the hypotenuse. So here the middle point of the hypotenuse would be 0, 3. Sorry, so sorry. I have said for the circumcenter, and for the orthocenter, it would be at the vertex at where it's making right angle. So here it's B, and it is 0, 3. Sorry to mention that I didn't say that if there is a right angle triangle, the orthocenter would be the right angle point. So yeah, you have to note it. And we'll go for the next question. The centroid and the circumcenter of the triangle are 3, 3 and 6, 2. Then its orthocenter is. So here we have the centroid point and the circumcenter point. We know that centroid divides the circumcenter and the orthocenter in 2:1 ratio. So we'll take the orthocenter as alpha, beta, and then we'll use the formula here, and you'll get that the orthocenter is 3, 5. And some other points about the triangles and quadrilaterals and other polygons, that if you want to find the area enclosed by the vertices ABC, then the formula would be half of delta x1 y1 1, x2 y2 1, x3 y3 1. And if you elaborate it, and if you solve the delta, you'll get half of mod x1 y2 minus y3 plus x2 y3 minus y1 plus x3 into y1 minus y2. You have used mod as the area is always positive. And if you have an equilateral triangle with a side length a, then the area would be root 3 by 4 a square. And if you know the altitude length, which is p, then the area would be p square by root 3. And if you have a triangle with the polar coordinates r1, theta 1, r2, theta 2, r3, theta 3, then the area would be half of r1, r2 sin theta 2 minus theta 1 plus r2, r3 sin theta 3 minus theta 3, and plus r3, r1 sin theta 1 minus theta 3. And you have to mention, you have to understand that if the sides are if the sides are integers, then the area should always be in the roots thing. And area, if the area is rational number, then the triangle cannot be equilateral. So we also know that if any points are lying on the same line, those are called collinear points. So if any 3 points which are collinear, then the area enclosed by it, even if it forms a triangle, it would be 0. So the delta equal to 0, and by putting that, you can solve the equation for the line which is passing through ABC by taking one coordinate x as x, y, and the other two as some coordinates, any two coordinates. And also you can use this thing that AB plus BC is equal to AC or any other 2 points. So here for the quadrilateral area, if you have the 4 vertices, then area would be half of mod of x1 y2 minus x2 y1 plus x2 y3 minus x3 y2 plus x2 y4 in that way. And if you have two opposite vertices of rectangle given, then the area would be mod of y2 minus y1 into x2 minus x1. And if you're given with the two opposite vertices of a square, then the area would be diagonal square by 2, which is nothing but half of mod x2 minus x1 whole square plus y2 minus y1 whole square. And in a similar fashion, if you want to find a polygon area formed, formed by the coordinates here, then it would be in this fashion. Or we can use their method here. We can see that delta. And we'll solve some questions. Area of a triangle formed by the points a comma b plus c and b comma c plus a comma c comma a plus b. And from that, we know the formula for the area, and you'll solve that form. Even you will um, solve those equations, and then you'll get the area as 0, which means those 3 points are lying on a same line, or those 3 points are collinear. And for the next question, you have given 3 points and a point. Then the ratio of the triangle ABC and triangle PPC. Triangle PPC has a term x comma y involved, and the triangle ABC you can find it from the area formula, and you will get it as a mod of x plus y minus 2 by 7. And for the next question, you have given with the vertices, and you have given the area, and we have to find the centroid. So here we need to find the value of k, and then we can go for the centroid formula. So here we know the area. So if you write the area formula equation, then you can get as k is equal to plus or minus x. So when we consider k greater than 0, which is mentioned in the question, then the points would be 12, 6, 6, 12, 6, 6, and centroid would be, we know the centroid formula, and when we apply it, we'll get the point as 8, 8. And here we have given 3 points, and these 3 points are collinear. As I said before, the area enclosed by any 3 collinear points would be 0. So here we know the area formula, and when we solve for it, we'll get the x value, and from that you can just select the options. And for the next question, you have been given 3 points, and those 3 points are collinear. So again, you have to use the formula for the area, and then you have to solve the equation with theta, and then you will get 0 equal to 0. As here you can see, the left hand side and the right hand side are equal. So that means for any theta value, those three would be collinear points. So except the cosecant theta and secant theta should be defined values. So you shouldn't take 0 or pi by 2 or any multiples of pi by 2. So for the next question, you have been given 3 vertices and you are asked to find the triangle formed by those 3 vertices. As I said before, you have to, whenever you're given with your 3 vertices, and if you wanted to know which type of triangle it is, you have to first find the distances between these 3 points. So here you'll go AB, BC, AC, you'll find them, and you'll get here 81 root 10 by 9 and 82 root 10 by 9 and root 10 by 9. So as you can see here, it's nothing but these three doesn't form a triangle because AB plus BC is not greater than the AC, and it is in fact equal to AC, which is nothing but the condition for the collinear points. These 3 points are collinear. So the option would be none of these. And we'll solve some other questions. So here there is a line which is passing through minus 5, 4, and it meets the line x plus 3y plus 2 and 2x plus y plus 4 equal to 0, and x minus y equal to 0 at points b comma c comma d. And here we had a relation between ABC, AC and AD. So we are asked to find the equation of the line. So what you'll do here is, whenever you are given with a point and a line passing through it, then if you imagine a point on the line, the distance r1, then the coordinates would be x1 plus r1 cos theta and y1 plus r1 sin theta. So here at the r1, if the point lies on that line, you can, like, by using that uh, property, we can just solve this question. So we'll go with that main. So here, if I think that if the point A, I mean, if the line meets the axis, I mean, if the line meets the line x plus 3y plus 2 at some b dash, then, I mean, at b, then the distance AB would be the r1, and so the coordinates on that line, I mean, the coordinates at that point would be AB cos theta plus 5, I mean, x plus 5 is equal to AB cos theta, and y plus 4 equal to AB sin theta, and those x1 comma y1 would be lying on the line x plus 3y plus 2 equal to 0. In a similar way, you can find for the 2x plus y plus 4 and x minus y minus 5. And from that, you'll get the x coordinates, y coordinates for all these series in terms of R1, I mean, in terms of AB, AC, and AD, and cos theta, sin theta. So from there, you'll see that R1 equal to 15 by cos theta plus 3 sin theta, where R1 is AB. So 15 by AB would be cos theta plus 3 sin theta. And similarly, you'll get 10 by AC and 6 by AD2. And when you keep these terms in that equation, in that relation, you will get tan theta equal to minus 2 by 3. So from there, you got theta value. So R1 you can find, and or else you can just go, I mean, you just know the point and the angle made by the line. So you know that tan theta equal to minus 2 by 3, which is nothing but the slope, and y plus 4 is equal to m into x plus 5, which is nothing but from there you can find the equation. And here the next question says that the equation of the two equal sides of an isosceles triangle are 7x minus y plus 3 equal to 0 and x plus y minus 3 equal to 0. The third side passes through the point 1 comma minus 10. The equation of the third side is. So here we have two equal sides and we have the equations of the two sides. The third side which is passing through the point minus 1 comma minus 10. So any line passing through 1 comma minus 10 would be in the form y plus 10 equal to m into x minus 1. Since it is making equal angles with these two sides, as it is mentioned as an isosceles triangle, it should make equal angles between those two. So if you find the angle tan alpha, then you will get m minus 7 into 1 plus 7 and m plus 1 into m plus 1 by 1 plus m, which is nothing but m equal to 1 by 3 or 3. So we'll have two possibilities for the third side, which are these two. And when you go for the third question, here they given the graph of the function as cos x plus 2 minus cos square x plus 1. Here it is nothing but the manipulation of the trigonometric functions. So here cos x into cos x plus 2, which is in the form cos a into cos b, I mean cos of a into cos b, or else cos of x plus 1 minus 1 into cos of x plus 1 plus 1, which is nothing but cos of a minus b into cos of a plus b. So we can write, we can use the formula that cos of a plus b into cos of a minus b is equal to cos square a minus sin square b. So here cos square x plus 1 minus sin square minus cos square x plus 1, which is nothing but minus sin square 1. So y equal to minus sin square 1, which is nothing but a line which is parallel to x axis, and with the coordinate y equal to minus sin square 1. So here you can say that a straight line passing through point pi by 2 minus sin square 1. As it is a parallel to the x-axis, it has all whole x values, minus infinity to infinity. And for the fourth question, in what direction can a line be drawn through the point 1, comma 2, so that its point of intersections with the line x plus y equal to 4 is at a distance of root 6 by 3 from the given point. So here we have given the angle and the point and the distance. We have to find the coordinates of the point, which is at a distance root 6 by 3. So as I said previously, x minus 1 by x minus 1 would be the r1 cos theta. So here x minus 1 equal to root 6 by 3 cos theta. Here cos theta is 1 by root 2 and sin theta is 1 by minus 1 by root 2. So here you can just solve it and then you'll find the x coordinate and y coordinate. And for the next question, the area enclosed within the curve mod x plus mod y equal to 1 is the given lines are, we have four lines. So plus or minus x plus or minus y is equal to 1, which is nothing but a quadrilateral side. So if you see the intersection points of all these four, any of these two lines, you will get four vertices A, B, C, D. And so A, B, C, D, if you see that these are obviously a square because the coefficients of all those, and also these are perpendicular, so you'll get a square obviously, and the length of the each side would be root over a. If you see, if you find the distance between AB, it would be the side length, which is nothing but root 2. So the area would be a square, which is nothing but 2. So here you can also go for the next thing, next question. So here they asked for the locus of a point which divides the line joining 1, comma 0 and 2 cos theta, comma 2 sin theta internally in the ratio 2:3. So here we will use the section formula, and from that you'll find that let the coordinates of the point be h, comma k, and from there you will find the h coordinates and k coordinates in the terms of theta by using the sectional formula. You'll get 4 cos theta plus 3 by 5, 4 sin theta by 5. And from that, if you solve for the cos theta and sin theta, it would be 5h minus 3 by 4 and 5k by 4. So we all know that cos square theta plus sin square theta equal to 1. So when you substitute cos square theta and sin square theta, and with terms of h comma k, you will get the locus. And as you can see, it is a circle. So the locus would be a circle. We'll go for the next question. The area of the parallelogram formed by the lines ax plus or minus by plus or minus c equal to 0 is. So here again we have four equations, and here we don't know the angle between them. So we'll just assume it is a rhombus, and we'll find the vertices as we did for the square question. So we'll get the coordinates as A, C, B, D. And as you can see here, the diagonals are perpendicular. So we can also see from the question that if the lines are in the form ax plus or minus by plus or minus c, then obviously it should form a rhombus or a square. So from that you can say it is a rhombus, and area of a rhombus would be half into diagonal into half of the products of the diagonals. So here AC into BD, which is nothing but 2c square by AB. So we'll go for the next question. The points 1, comma 3 and 5, comma 1 are the opposite vertices of a rectangle. The other two vertices lie on the line y equal to 2x plus c. Then the value of c will be. So here we know the vertices of the opposite, I mean of the diagonals, and the other two vertices lie in the line. So here they gave that the other two vertices pass through the line. So we know that the midpoint would be uh, same for both the diagonals. So whenever you find the diagonal vertices, you can find the midpoint of them, and that point should also pass through this line because the midpoint also lie on the same line which is passing through those two vertices. So from that you can just find the midpoint and then you can substitute in the line and you see. So we'll go for the next question. The equation of the lines which passes through the point 3, minus 2 and inclined at an angle 60 degrees and to the line root 3x plus y equal to 1. So we know that tan alpha equal to m plus or minus m1 plus m2 by 1 minus m1 m2. Here we know as the sum of the angles. So here we are finding this difference. So m1 minus m2 by 1 minus 1 plus m1 m2. So here we know the m1 which is minus root 3 and we have to find m2. So 60 tan 60 equal to plus or minus of m minus of minus root 3 by 1 plus m into minus root 3. From here we'll get m equal to 0 or root 3. If you substitute y equal to, y plus 2 equal to m into x minus 3 m values, you'll get two equations. So, and also we'll go for the next question, which is the slope of a line is passing through point A 3, comma 2 is 3 by 4. And the points on the line which are 5 units away from the point. As you can see here, we have the cos theta and sin theta. You want to know the points. So here the r can be positive, r can be negative because it can be ahead of the point or before the point itself. So you can just use the formula with r as negative and positive minus or plus or minus 5, or else you can take the point can be h comma k, and as it is lying on that line 3x minus 4y minus 1 equal to 0, you can find an equation, I mean relation between h comma k and from that. And also it is giving that it has given that it has 5 units from the point. So we can use the distance formula h minus 3 whole square plus y minus 2 whole square equal to 5 square. From that you can solve those three equations and you'll get the